Good morning to all. In this video, we are going to discuss about steam turbines. Okay, a steam turbine is a prime mover in which the potential energy of steam is converted into kinetic energy and later transformed into mechanical energy of rotation of turbine shaft. Okay, so here whatever the energy by means of nozzle, a steam jet will strike the turbine blades, and that whenever it strikes the turbine blades, the potential energy is converted into the kinetic energy, that is rotational energy, and then the rotational energy is transformed to the shaft. In the shaft, the mechanical energy will be produced. Okay, so the turbine shaft is connected directly or by reduction gearing to driving mechanism. That is, whatever the work we require, we can develop the turbine rotational turbine work to the mechanical energy of work to the any work, whatever work we have required. Okay, next one is, depending on driving mechanism, it can be used for many purposes. That is based on the mechanism you are whatever using, we can use it for different purpose. That is for electrical energy generation, or for running of any wheels, like that, whatever required, we can use that power. Okay, so now we are having different classifications of steam turbines. So first, in that, according to the action of steam, the steam turbines are classified into three types. First one is impulse turbine. Okay, so here in impulse turbine, the impulse turbine, the steam coming out through a fixed nozzle at high velocity strikes the blades fixed on the periphery of the rotor. Okay, the blade will help us to change the direction of the steam flow without changing its pressure. So here the impulse turbine consists of a set of fixed blades and moving blades. First, a fixed blade is struck, and the fixed will help to change in the direction of the flow. So the steam flow without changing its pressure. The force due to the change in moment causes rotation of the turbine shaft. So whenever it hits the moving blade, the change in momentum will be created. That will help us to create the turbine shaft, rotate the turbine shaft. So example for this steam turbine, impulse turbine or D-level turbine, Curtis turbine, and Raytube turbine. Okay. So next type is reaction turbine. So here in reaction turbine, the steam expands both in fixed and moving blades continuously as steam passes over them. So the reaction turbine consists of set of fixed blades and moving blades. In both fixed blades and moving blades, the expansion of steam will takes place, and finally, after leaving the turbine, the pressure drop occurs. So next one is combination of impulse and reaction turbine. So that is, it consists of a fixed nozzle and set of fixed and movable nozzles in the combination of impulse and reaction turbines. Okay. So next, according to the number of pressure stages. So we are having the next type of classification is according to number of pressure stages. We are having two types of pressures. One is single stage turbine. Okay, so these turbines are mostly used for driving centrifugal compressors, blowers, and other similar machineries. Okay, so next one is multi-stage impulse and reaction turbines. So here these are used for wide range of power generation, varying from small to large. Okay, so next, according to the type of steam flow. Okay, so first one is axial turbine. In this, first type of turbine is axial turbine. Okay, so in this turbine, the steam flows in a direction parallel to the axis of the turbine. So if the steam flows in direction parallel to the axis of the turbine, that is called as axial turbines. Okay, so if the steam flows in the direction perpendicular to the axis of turbine, and it is called as radial turbines. Okay, next, according to the number of shafts, it may be single shaft turbine and multi shaft turbines. Okay, so next one is according to the method of governing. Okay, a turbine with throttle governing system, turbine with nozzle governing system, turbine with bypass system. Okay, so in turbine with throttle governing system, the fresh steam enters through one or more turbines simultaneously operated by means of throttle valves. Okay, so by means of throttle valves, one or more number of turbines can be operated. So turbine with nozzle governing system. So in these turbines, the fresh steam enters one or more consecutively opening regulators. So turbine with bypass system. So here the first stage is also directly fed to 1, 2 are governings. Okay, in these turbines, the steam besides being fed even 3 intermediate stages of the turbine. Okay, so like that in suppose in regeneration system or bleeding system, we are extracting the steam at one or more points and we are reheating and resupplying to the turbines. So in the case of reheating system, we are completely extracting the steam from one point and we are supplying to the another turbine. Like that, we can utilize we can operate at a similar time one or more number of turbines. Okay. Next, according to the steam condition inlet to the turbine, low pressure turbines. So the turbines which are operating between 1.2 to 2 bars, that is called as low pressure turbines. Medium pressure turbines up to 40 atmospheric pressures, and high pressure turbines are above the 40 atmosphere pressure, then we can call it as an high pressure turbines. Okay, very high pressure turbines are above 170 atmosphere pressure and temperatures are above 550 degrees centigrade, that is superheated region temperatures. Such type of turbines are called as very high pressure turbines, and supercritical pressure turbines. Okay, so next, according to their uses in the industry, so the turbines are stationary turbines with constant speed, stationary turbines with variable speed, non-stationary turbines. Okay, so the stationary turbines are primarily used as alternators. The stationary turbines with variable rotation are used to drive blowers or air circulators, pumps, etc. And non-stationary turbines with variable speeds are employed in ships, railway locomotives, steam engines, steamers, like that. Okay. Now, what are the advantages of steam turbine over steam engines? Okay. The thermal efficiency is higher compared to the steam engines. This, as there are no reciprocating parts, perfect balancing is possible. Therefore, heavy foundation is not required. Higher and greater ranges of speeds is possible. Lubrication is very simple. The power generation is at uniform rate, hence no flywheels is required. Okay. So next one is advantages of steam turbine over steam engines. Some more advantages are: the steam consumption rate is less, more compact and require less attention, more suitable for large power plants, less maintenance cost, considerable overloads can be carried at expense and slight reduction. So now, what are most commonly used steam turbines are simple impulse turbine and reaction. Turbine. Okay. First, we are going to study simple impulse turbine. Okay. So this is the layout of simple impulse turbine. Okay. So the primary set of nozzle and a rotor mounted on the shaft, one set of moving blades attached to the rotor, and a casing. Okay. So here for the single shaft, a set of moving blades and fixed blades are arranged. The simple impulse turbine is also known as D-level turbine. Okay. So here this turbine is called as simple impulse turbine since the expansion of steam takes place in only one set of nozzles. Okay. Now, as steam flows through the nozzle, the pressure falls from chest pressure to the condenser pressure. As steam flows to the nozzle, here the nozzles are arranged shown in figure. So whenever the steam flows through the nozzle, the pressure drop will be takes place initially. Pressure drops will be takes place initially, and kinetic energy increases. Okay. So due to high ratio of expansion of steam nozzle, the steam leaves the nozzle with high velocity. Okay. Now the velocity of steam moving the blade is large portion and maximum velocity of steam leaving the nozzle. So here the steam which is leaving the blade portion velocity is large portion of maximum velocity of steam leaving the nozzle. Okay. Since it consists of only one set of rings, the total kinetic energy is absorbed by the rotor and speeds may be 30,000 rpm. Okay. See here we are having only one set of rotors. So whatever the kinetic energy generated by the nozzle, that kinetic energy is entirely passed to the rotor blades. So the total kinetic energy is absorbed by the set of rotor blades, and the turbine shaft will be rotated at a speed of 2000 rpm. That is higher speeds the turbine will be rotated. Okay. So the rotor speeds can be reduced by using different methods. Those methods are known as compounding methods or compounding techniques. So we are having three types of compounding techniques: velocity compounding, pressure compounding, pressure and velocity compounding techniques. Okay. Now, what are the certain disadvantages of the impulse turbine? Okay. Since all kinetic energy and of the high velocity steam to be observed in only one ring of moving blades, the velocity of the turbine is too high, that is up to 30,000 rpm for practical purposes. So as I said, the total kinetic energy developed by the nozzle is passed to the only one set of moving blades. Then the total kinetic energy is absorbed by only that moving blade set. So hence the speeds are very higher that are not practically used. Okay. So now the velocity of the steam at exit is sufficiently high, which means that there is a considerable loss of kinetic energy. The kinetic energy loss is very high at the exit of the nozzle. That means the pressure drop is very high. Okay, more than the condenser pressure. Okay. Next type of turbine is reaction turbine. Okay. So in the reaction turbine itself acts as one of the compounding technique. It itself acts one of the compounding technique. Okay. So in this turbine, there is a gradual drop of pressure by passing through fixed and movable blades. So here we are arranging a set of fixed and movable blades in number of stages. Okay. So you see, if you observe the figure, we are having fixed blade and then movable blade, again fixed blade and again movable blade and again fixed blade and again movable blade. Okay. So now what is the function of fixed blade? The function of fixed blade is just to alter the direction of steam. What happens in the moving blade? In the moving blade, the steam velocity is observed and rotation of the blade will takes place. Okay. Now, the function of fixed blade is that they alter the direction of steam as well as it expands steams to large velocities. Okay. Now, as steam passes over the moving blades and strikes the moving blade, there is a loss in kinetic energy. Will be takes place, and hence there is a drop in pressure. Okay. See, if you observe the steam velocity and pressure diagram, the pressure is continuously going to be dropped in fixed and movable blades, and when in the fixed blade the velocity increases, in the movable blade velocity drops, and again fixed blade velocity increases, because the fixed blade itself will acts as a nozzle. Okay, and again it is reaching, whenever it reaches the movable blades and passes over the movable blade, the velocity drop will be takes place. Okay, now whatever the exit pressure, that is equal to the back pressure is less, and leaving velocity will be reduced in the reaction turbine. Okay. So in the reaction turbine itself acts as one of the compounding method to reduce the rotor speeds. Thank you.